In this video, we shall be discussing on the characteristics function of a random variable, and we shall also obtain the expectation and variance for the binomial distribution. The first thing to do is to write the characteristics function for the binomial distribution, which is q plus p exponential it raised to the power of n. The first thing to do is to obtain the expected value of x, or the expectation of x. The first thing to do is to take the first derivative of the characteristics function of the given binomial distribution. For more on this topic, you can subscribe to this channel. So taking the first derivative, we get n into q plus p exponential it into n minus 1 multiplied by, from function of a function method of differentiation, we differentiate this. So we have p, we also have the characteristic function multiplied by exponential it. So rearranging this, we can write it as n, we bring down this p I into q plus p exponential it raised to the power of n minus 1 multiplied by exponential it. So this is the first derivative of t. So we now say at t equal to 0, at t equal to 0, we move over to this other side of the board. At t equal to 0, our characteristic function will be written as this. So the next thing to do is for we, anywhere we see t, we put 0. So we have n pi into q plus p exponential I into 0 raised to the power of n minus 1 multiplied by exponential I 0. Of course, anything raised to the power of 0 is 1. That is, if you have exponential I into 0, it's the same thing as exponential 0 and is equal to 1. Because anything raised to the power of 0 is equal to 1 from indices. So we have that the characteristics function at t equal to 0, we have np into q plus p, because this has turned to 1, so we have n minus 1. This has also turned to 1. Also, from probability distribution, we have that the probability of q plus p, that means the probability of success plus failure, is equal to 1. So it then means that our characteristic function of x is equal to, I, is equal to npi. So if this is 1 raised to the power of anything is the same thing as 1. So we now have that our expected value of x is equal to negative characteristics function of the first derivative at 0 will be equal to negative I multiplied by npi, which is the same thing as negative I squared multiplied by np. Of course, we know that from our characteristics function, negative I squared is equal to, I squared is equal to negative 1. So we have that our expected value of x is equal to negative minus 1 multiplied by np. So it then means that our expected value of x is equal to np. So we also need this when we are calculating for the variance. So we have succeeded in obtaining the expectation of x. The next thing to do is to find the expected value of x squared. The expected value of x squared. That will now enable us to obtain the variance. So we move over to this other side. We should recall that when we differentiated this, we got this. So to obtain the expected value of x squared is for we to find the second derivative of the characteristics function of the binomial distribution. So what we need to do first is to recall that the first derivative will give us n into q plus p exponential it raised to the power of n minus 1 multiplied by pi exponential it. So we can now clean this. So for more of this topic, you need to subscribe to this channel. So to obtain the expected value of x squared, like I said, we'll have to find the characteristics function of the second derivative of x at t. So what we need to do, we'll use what is called the product rule of differentiation. That product rule states that u the v all over the t, because we are differentiating with respect to t, plus v the u all over the t. Of course, this is our u and this is our v. So all we need to do is to take the derivative, the second derivative. It then means that our characteristics function will be equal to u. U, we bring it here, n into q plus p exponential it raised to the power of n minus 1. This is our u. The v all over the t. That means we differentiate this. The v all over the t will have p. This becomes I squared because I will come down. Then we have exponential it. We succeeded in differentiating this. Now we say plus v. We bring down our v. V is p I exponential it. Now we differentiate this. The u all over the t. The u all over the t. The u all over t may not enter here, so we bring our hand down to write it as n into n minus 1 into q plus p exponential it. So this is what we get. Now, as we are differentiating this function, we also differentiate the function that is inside. So differentiating this function inside, we get multiplied by this turns to n minus 2, because n minus 1 will give us n minus 2 multiplied by the differential inside. We have p I exponential it. So this will be written out well. So this is multiplied by this. So we'll write it out well properly here. We'll write our characteristic function properly here. We should recall that our expected value of x is equal to np. So rewriting this out properly, we have that our characteristics function is equal to n into q plus p exponential it n minus 1 multiplied by p I squared exponential it plus p I exponential it. Now we'll write this out, multiply by n into n minus 1 q plus p exponential it raised to the power of n minus 2 multiplied by p I p I t. So rearranging this, we have our characteristic function to give us this p can come over here. We have n p I squared into q plus p exponential it raised to the power of n minus 1. Since this has moved over to this side, we only have exponential it here. Plus, this is p and this is p. So, this will multiply this, I will multiply I to give us p squared, I squared, exponential it into n multiplied by n into n minus 1. Then we have q plus p exponential it n minus 2 multiplied by, since this has gone over to this side, we just have only exponential it. So the next thing to do, we say at t is equal to 0. At t equal to 0, it means that our characteristic function at t equal to 0 will give us, anywhere we see t, we put 0. So we have np I squared into q plus p exponential I 0 into n minus 1 plus p squared I squared exponential I 0 into, now we write this out properly, n into n minus 1 multiplied by q plus p exponential I 0 raised to the power of n minus 2 multiplied by exponential I 0. Of course, exponential I 0 is equal to exponential 0 is equal to 1. It then means that anytime we see e raised to the power of I 0, it becomes 1. It becomes 1. So for more on this topic, you need to subscribe to this channel. It then means that our characteristic function will now be np I squared. Of course, this is 0. We have q plus p only, plus, okay, we have to write p I 0, which is this. Then we have plus p squared I squared. This becomes 1. So we have n into n minus 1 into q plus p. This becomes 1. So we have n minus 2 and this becomes 1. Of course, we know that from probability distribution, q plus p is equal to 1. So anyhow we see q plus p, we write